Good morning, class. Our topic, the sequence and series. Many situations in the field of science and mathematics involve numbers arranged in a definite order or sequence of numbers which are related to each other, such as minutes in an hour, the successive powers of 10, the square of integers, etc. In this chapter, we shall discuss the type of sequence and series and later recognize the presence of them in a real-life situation. Without pencil and paper. So what is the sum of the first 100 positive integers? 1 plus 2 plus 3 plus and so on, plus 98 plus 99 plus 100. So that was what Ghost did when he was a young schoolboy. Then what is sequence or progression? Sequence or progression is a set of numbers written in a special order by the application of definite rule. Then what do you call each term? Each term of the sequence is called a term. The first number is called the first term, then followed by the second term, the third term, and so on. So, like example, we have the sequence and rule. 1 plus 1, 4, 9, 16, 25. And we have another example, 2, 4, 6, 8, 10. So, the example number 1. Okay, what is the rule? Okay, so the rule in example number 1 is squaring counting numbers 1 to 5. Then rule number 2. Every term after the first is obtained by adding 2 to the preceding one. Then we have here the definition of series. Series is indicated sum of the terms of a sequence. The word series can be used both in singular and in plural. So, using the example of sequence, 1 plus 4 plus 9 plus 16 plus 25. And then another example, 2 plus 4 plus 6 plus 8 plus 10. So those are the example of series. So it is indicated in a sign plus. Then in sequence is a function whose domain is the set of positive integers. Subscripts are used to designate the member of terms. Okay, example number 1. Write the first 4 terms of the sequence y is equal to x positive 1. Then you have to write the first 4 terms by using the counting number from 1 up to 4. Okay, so we have y is equal to x positive 1. The first counting number is equal to 1 plus 1. So y is equal to 2. 2 is the first term. Then next is y is equal to x positive 1. Then the second counting number is 2. 2 2 plus 1. So, we have here 2 plus 1 is equal to 3. So, 3 is the second term. Then, next is y is equal to x positive 1. Okay, so we have 3 plus 1. So, we have 3 plus 1 is equal to 4. So, 4 is the third term. Okay, last. Okay, so you are only right for first 4 terms. Okay, so y is equal to x positive 1. Okay, that is 4 plus 1. So that is 4 plus 1 is equal to 5. 5 is the fourth term. So therefore, the first 4 terms is we have 2, 3, 4, and 5. So this is now the first 4 terms. For example number 2, the same instruction. Now write the first 4 terms of the sequence y equals 2x. Okay, still just use counting number from 1 up to 4. Okay, y is equal to 2 multiply it by 1. 1 is the first counting number. So we have 1 times 2, so that is 2. So 2 is the first term. Then let us solve the second term. Okay, y is equal to 2x. Then we have here 2 multiply it by 2, so is equal to 4. 4 is the second term. Then next, so solve the third term. Okay, so y is equal to 2x, then that is 2 multiplied it by 3, so that is 2 times 3, so the product is 6. So 6 is the third term. Then last, the fourth term. Okay, y is equal to 2x, then that is 2 multiply it by 4, so the fourth term is 8. So y is equal to 8. So therefore, the first 4 terms of the sequence y is equal to 2x is 2, 4, then we have 6, then 8. So this is now the first 4 terms of the sequence y is equal to 2x. For example number 3. So we have the given sequence y is equal to x squared negative 9. Then write the first 4 terms. Okay, so use the counting number from 1 up to 4. So we have here, let us solve the first term. So x 1 squared negative 9. So we have the square of 1 is 1. Negative 9. So the first term is equal to negative 8. Then next, okay, solve the second term. Okay, y is equal to x squared negative 9. So the second counting number is 2. We have 2 squared minus 9. The square of 2 is 4. Then we have minus 9. So the second term is negative 5. The second term is negative 5. Then for the third term, y is equal to x squared negative 9. That is, so 3 squared, we have negative 9. The square of 3 is 9. Then minus 9. So the third term is equal to 0. The third term is equal to 0. And then, last, okay, y is equal to x squared negative 9. So we have here 4 squared minus 9. So the square of 4 is 16. So 16 minus 9 is equal to 7. So 7 is the fourth term. So therefore, we have the sequence, the first four terms of the sequence y is equal to x squared minus 9. So that is negative 8, negative 8, negative 5, then we have 0, then we have positive 7. So this is now the sequence, the four terms of the sequence y is equal to x squared negative 9. For example, now we have the given sequence y is equal to 3x positive 5. So write the first four terms. Okay, let us solve the first term. Okay, we have y is equal to 3 multiply it by 1 plus 5. So the first term is we have 3 plus 5 is equal to 8. So this is now the first term. Then we have the second term, y is equal to 3 multiply it by 2, then we have positive 5. Then 2 times 2, 6. Then plus 5. So we have the second term is equal to 11. Then next, the third term, y is equal to 3x positive 5. So we have 3, multiply it by 3, then we have plus 5. So 3 times 3, so we have the product is 9. Then plus 5. So therefore, that third term is equal to 14. Then last, the fourth term. Okay, so y is equal to 3x, then positive 5. Okay, so 3, multiply it by 4, then positive 5. So 4 times 3, so the product is 12 plus 5. So that fourth term is equal to 17. So therefore, the first four terms of the sequence, 3x positive 5 is equal to 8, 11, 14, and 17. Okay, for example number 5. So write the first four terms of the sequence y is equal to x open quantity 2 minus x then close quantity. Then let us solve the first term. So we have the first counting number is 1. Multiply it by 2, then minus 1. Okay, so we have a 1, then multiply 2 minus 1 is equal to 1. Then we have, after that, multiply. So 1 times 1 is equal to 1. 1 is the first term of the sequence. Y is equal to x open quantity, 2 minus x then close quantity. Then for the second term, y is equal to x open quantity, 2 minus x then close quantity. Then we have the second counting number is 2. Then we have 2 minus 2. Okay, so we have here 2. Then 2 minus 2 is equal to 0. So we have 0 times 2. So we have the product is 0. 0 is the second term. Then next, we have the third term. Okay, y is equal to x. Then open quantity 2 minus x. Then we have close quantity. So the third term is, the third counting number is 3. Then we have multiply it by 2 minus 3. Okay, so we have here 3. 2, positive 2 minus negative 3. So we have negative 1. Negative 1. Okay, then we have multiply. Negative 1, multiply it by 3, so the product is negative 3. Negative 3 is the third term. And then for the last term, okay, we have y is equal to x open quantity 2 minus x. Then we have the four counting number. We have here 4. 4 multiply it. We have 2 minus 4. Okay, so we have 4. Positive 2 minus negative 4. So this, we have here negative 2. Okay, so multiply. Negative 2 times 4. So we have here negative 8. So therefore, the first 4 terms of the sequence, x open quantity to negative x, is we have 1, then 0, then we have negative 3, then we have negative 8. Another subtopic, we have arithmetic sequence or progression. From the definition of sequence, you learn that the list of numbers are so related in some way to preceding terms of the counting numbers of the terms. The function is expressed in an equation following the special order of the terms. Arithmetic sequence or progression is a sequence in which each term is obtained by adding a constant d to the preceding term. The fixed number added is called the common difference. Then we have the formula to be followed in solving the last term. Okay, so the formula, a, the subscript of n is equal to a, the subscript of 1, plus open quantity n minus 1, then close quantity d, where a, the subscript of 1, is the first term. Then a, the subscript of n, is the last term. Then n stands for the number of terms. And d stands for the common difference. Okay, find the 14th term in the sequence of 5 plus 5, 7, 9, and 11. So, the formula, we have n, the subscript of 1, plus open quantity n minus 1, then close quantity, multiply it by d. Okay, so we have plus the number of terms. The number of terms is 14. No, the number of terms is 14. Then minus 1 is constant. Then next is d. D stands for common difference. How to get the common difference? To get the common difference, by subtracting, we have, so 7 minus 5, 2. Then we have 9 minus 7, 2. Then 11 minus 9, 2. So therefore, common difference is 2. Okay, so multiply it by 2. Then we have 5 plus 14 minus 1, that is 13. Then multiply it by 2. So we have here 5 plus 13 times 2, we have 20, 26. Okay, then add 5 plus 26 is 31. So the last term is equal to 31. Then checking. So if the last term is 31 and the 14th term. Okay, the first term is we have 5, then we have 7, then 9, 11, Then 11 plus 2, that is 11 plus 2 we have 13. 13 plus 2, okay, we have 15. 15 plus 2, 17. 17 plus 2, we have 19. 19 plus 2, we have 21. 21 plus 2, okay, we have 23. 23 plus 2, we have 25. So 25 plus 2 is 27. 27 plus 2 is 29. Then 29 plus 2 is 31. So the last term is 31. Count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 term. So therefore, the last term is 31. Okay, example number 2. Find the 11th term in the sequence 3, 4, 5. Then find the last term. Now solve the last term. Okay, so we have here a, the subscript of n is equal to a, the subscript 1 plus n, then minus 1, then we have d. Okay, so the first term is 3, then plus the number of term is 11 minus 1. Then what about the common difference? Okay, the common difference is, okay, so 4 minus 3 is 1. Then we have 5 minus 4 is 1. So therefore, common difference is 1. Okay, so 3 plus, then open quantity 11 minus 1, that is 10. Then multiply it by 1. So we have here 3. So 10, multiply it by 1, that is 10. Okay, so 3 plus 10 is 13. So 13 is the last term. Then checking. So we have the first term is 3. Then we have 4. Then 5. 5 plus 1, 6. 6 plus 1, 7. 7 plus 1, 8. Then 7 plus 1, 9. Then 9 plus 1 is 10. 10 plus 1 is 11. 11 plus 1 is 12. Then we have 12 plus 1 is 13. Then count. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. For number 3 example, find the 12th term in the sequence 5, 9, 13. Okay, so we have the formula for solving the last term, that is a, the subscript of 1 is equal to a, the subscript of 1 plus, then we have open quantity n minus 1, then multiply it by common difference. Okay, so the first term is 5, then plus the number of term is 12 minus 1. Then the common difference is 4. Okay, then simplify. We have 5 plus 12 minus 1 is 11. Then multiply it by 4. Okay, so we have 5. 11 times 4 is equal to 44. Then add. Okay, so we have 5 plus 44 is equal to 49. So the last term is equal to 49. Then checking. Okay, we have the first term 5, then we have 9 plus 13. 13 plus 4 is 17. 17 plus 4 we have 21. 21 plus 4 we have 25. 25 plus 4 we have 29. 29 plus 4 is 33. 33 plus 4 we have 37. 37 plus 4 is 41. 41 plus 4 is 45. 45 plus 4 is 49. Okay, so count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 terms. For our activity, okay, you write it in a yellow pad paper. Then we have here the instruction. Determine if the sequence is arithmetic. If it is, find the common difference.